I'll discuss about principal stress. So before discussing about principal stress, first I would just like to recall you what is stress. What is stress? We know stress is equal to P upon A, where P is equal to load, or we can say force. A is equal to area. So a stress is load per unit area. Load per unit area. That is called stress. This is sigma is called stress. The SI unit of a stress is Newton per millimeter square. Now the types of stress. Types of stress. Types of stresses. First one is tensile stress. Second one is compressive stress. Compressive stress. And third one is shear stress. Shear stress. So now I just draw the diagram of tensile stress, compressive stress and shear stress so that you can understand very well what exactly tensile stress is and what exactly compressive stress is. This is called tensile stress. Tensile stress. Tensile stress. Now we have compressive stress. Compressive stress. Compressive stress. This is called compressive. This is called compressive stress. Now we have shear stress. Shear stress. This is called the shear stress. This is called the shear. Now we have a body, and in this body tensile stress, compressive stress and shear stress, all these three stresses acting on this object. So here this is sigma x. This is sigma x. The tensile stress is acting here. Now the compressive stress is acting here. This is sigma y. This is sigma y. Now the shear stress is acting, tau xy. So in this particular object we have seen that tensile stress, compressive stress and shear stress, these three stresses acting on this object. So now we have to find the principal stress. Principal stress. We have a body and all three stresses are acting on this body and we have to find the stress. So now how we will find the stress? So we have principal stress. We can find out the principal stress of this object. So we can say principal stress is called the summation of tensile stress, compressive stress and shear stress. If we will have sigma x plus sigma y plus tau xy, then easily we can find the principal stresses. Now we have two types of principal stresses, that is called maximum principal stress. Maximum principal stress. This is sigma 1. Now we have minimum principal stresses. Minimum principal stresses, this is sigma 2. We have the formula of maximum principal stress to find out the numerical. So sigma 1 is equal to sigma x plus sigma y divided by 2 plus under root sigma x minus sigma y divided by 2 whole square plus tau xy. Here where sigma x will be called as sigma y. Sigma y is equal to compressive stress. Compressive stress. And tau xy, that is equal to shear stress. This is shear stress. So this is the formula of maximum principal stress. Maximum principal stress. This is called sigma x, sigma y. Sigma x plus sigma y by 2 plus under root sigma x minus sigma y by 2 whole square plus tau x y. Now we have minimum principal stress. The formula for minimum principal stress, this sigma 1 will be called as maximum principal stress. Maximum principal stress. So sigma 2 is equal to sigma x plus sigma y divided by 2 minus under root sigma x minus sigma y divided by 2 square plus tau x y. Here this sigma 2 will be called as minimum principal stress, and this will be same. Sigma x will be tensile stress, sigma y will be compressive stress, and tau xy will be shear stress. Shear stress. Now find maximum principal stress and minimum principal stress. Here is the body acting sigma x. Sigma x is equal to 50 Newton per millimeter square. Sigma y is equal to 40 Newton per millimeter square. Now tau xy. Tau is equal to 30 Newton per millimeter square. So now given data is clear to you. What is given? Given is sigma x. Sigma x is equal to 40 Newton per millimeter square. Now what is sigma y? Sigma y is equal to 40 Newton per millimeter square. Now what is tau? Tau is 30 Newton per millimeter square. So now you have to find out the maximum principal stress and minimum principal stress. Here the data is given sigma x, sigma y and tau. What is sigma x? Sigma x means tensile stress, sigma y means compressive stress, and tau means shear stress. So the tensile stress, compressive stress and shear stress and is given to you, and now you have to find out the maximum principal stress and minimum principal stress. You have the formula of maximum principal stress. You have the formula of maximum principal stress, and maximum principal stress is denoted by sigma 1. So sigma 1 is equal to sigma x plus sigma y divided by 2 plus under root sigma x minus sigma y whole square plus tau xy का square. So now before putting the value of sigma x, sigma y and tau, you should clear one concept, that is sign using during putting numerical value, during putting numerical value. So if you have tensile stress, if you are putting the value of tensile stress, you have to take positive sign, you have to take positive sign. If you are putting the value of compressive stress, you have to take the negative sign of that value. Suppose you are putting the value of sigma x, so you have to take in the positive sign 50 Newton per millimeter square. But if you are putting the value of sigma y, that is compressive stress, then you have to take the negative sign. And now if you are putting the value of shear stress, so in shear stress, this is a body, this is, if you have to check the direction of shear stress. If the direction of shear stress is clockwise, if the direction of shear stress is clockwise, then you have to take positive sign. And if the sign is anti-clockwise, then you have to take negative sign, anti-clockwise. So now the concept is clear to you, that if you are putting the value of tensile stress, then you have to take the positive sign. If you are putting the value of compressive stress, then you have to put the negative sign. And if you are putting the value of shear stress, then you have to consider if the direction of the shear stress is clockwise, then you have to take positive sign. If the direction is anti-clockwise, then you have to put the negative sign. So in this numerical, you can see your direction is clockwise, so you have to put the positive sign. So now the value is given to you, you just put all these value in this maximum principal stress formula, you will get the maximum principal stress, and you just put all the data in the formula of minimum principal stress, that is sigma 2. You just have to here minus, and you just put all the value and you will get the data. So the principal stress and maximum and minimum principal stress concept I have already discussed. Thank you.